All right, so number 7, there's 4 parts. Again, they want us to list prime factorization and then find the least common multiple. Now, let me also go ahead and show you the dividing primes factor method, or the box method that I've been calling it. I really like that one. And then again, it's pretty close to the same as greatest common factor, just a little bit different. So all of these end in a 0. I don't have to divide out a prime number. I just want to divide something that they can all be divided by. So I'm going to start out with 10. Divide them all by 10. This becomes a 6. This is a 7. This is a 9. Okay. Then once you do that, you continue dividing, even if it's only 2 of them. Okay. So 6 and 9 are divisible by 3. 7 is not. So since I can divide 2 of them, I will divide 2 of them by 3. Okay. And I will divide this by 3 and write down 2, which is prime. I would leave that one alone because it wasn't divided, and divide this one by 3. Okay. Now, after that, they're all prime. I can't divide out anything else. You will take all the numbers on the outside, and it kind of makes like an L. And this will be your least common multiple. Okay, if you multiply 10 times 3 times 2 times 7 times 3, that will give you your LCM. So let's multiply those and see what we get, and then we'll do the prime factorization method, which is what they're asking for. If I do 10 times 3 times 2 times 7 times 3, we get 1,260. So we'll come back to that in just a minute. All right, so now let's do it with prime factors. So 60, 70, and 90. Divide by 10, that'll give us 6. 10 we can divide 2 and 5. And 6 can break down to 2 times 3. So these are all prime now. I have 2 2's, so I'll write 2 squared times 3 times 5. Alright, 7, I can do 10 and 7. 7 is prime. 10 I can break down to 2 and 5. Alright, these are prime. So 2 times 5 times 7. Alright, and then 90, 10 and 9, and then 10, 2 times 5, both prime after that, and 9, 3 times 3. So now that they're all prime, I have a 2 times 5 times 3 squared. All right, so once you get everything to prime factorization, that's one thing it's going to ask. Then to find your least common multiple, remember you take every factor that appears. So I have a 2, I have a 3, I have a 5. This one has 2, already got it. Has 5, already got it, but that also has a 7. So I'm going to add 7 down here. And then 2 already got it, 5, and 3. We already got all those numbers. So you list all the numbers, and then you go and find the biggest exponent. So here's a 2, here's a 2, here's a 2. Out of all these 2's, the biggest exponent is a 2. So I need 2 2's. Okay. Then I go to 3. The biggest on the 3 is a squared. So I need 2 3's. 5, it's only 1 5, so I only need 1, only 1 7. So here's my least common multiple. If you multiply 2 times 2 times 3 times 3 times 5 times 7, we should get 1,260, just like we got up above. So let's try that. 2 times 2 times 3 times 3 times 5 times 7. 1,260. So that's your least common multiple. Now, If you're not sure, let me go ahead and explain what least common multiple is doing. Least common multiple is finding the number that if you multiply 60, 70, and 90. So let's say we made a multiplication table. We multiplied times 1, times 2, times 3, and so on. So let's just do a few of them. 1 times 60 will be 60. 2 times 60, 120, 180, and then you would keep going. 70, and then 140, and then 210, and you would keep going. 90, 180, and then 270, and you would keep going. So this number, 1,260, is the first number that all three of them would have in common. So you see 2 of them have 180, okay? But this one doesn't get to 180. It goes past it. So we're trying to find the smallest, least common that they all would have in common when you multiply them all the way out. And so the best way of doing it is finding the primes or dividing method and seeing what they have in common and multiplying it together. Otherwise, this would take a long time, and we used to do it this way, like multiply 1, 2, 3, and keep going. So anyway, that's what the least common multiple is finding. Especially useful when you're trying to combine fractions and things of that nature. So the prime factorization of 60, I'm going to list it out. 2 times 2 times 3 times 5. You don't have to put it in exponential form. You can. Faster to type it out, so I don't have to use the keypad. With 70, 2 times 5 times 7. I'm not typing anything. 2, 5, 7. And then 90 was 2, 5, and 3, and 3. All right, and then lastly, we want to do our least common multiple, which is 1260.